Howdy everyone, hope you guys are doing well. A happy weekend. The last weekend of this year. It's actually interesting. 2026 was amazingly great. Panda, what's up? Yo yo. Oh sorry, 2025. 2025, yes. 2025 last weekend. Damn. Thank you. I think I'm living in the future right now almost. Thank you for catching that. No, yeah, this has been interesting. So today is we'll do some simple like lead code stuff, right? Like a problem from lead code 129, which is again top 150 interview problems. But also I want to like mention, so from tomorrow, like weekends will be my time. No streaming for like cybersecurity or anything, but there will be streaming of development where I'm just going to like silent or AMA type or just silent streams where just we'll play the ambience music and just get work done, right? Just need to get couple of things done, right? With AI and things, learning things and personal projects. So that will be on the table from tomorrow. Yeah. So people who want to read books or you want to get work done, you want to do any like other stuff, that would be the time. On the weekends we'll grind too, but limited grind. Okay. With that being said, let's get started with our stuff. Lead code or die. See, again, another amazing problem. 129 top 150 interview regarding trees. Some route to leaf numbers. It's a medium level one. Let's see the companies it got. So Meta, it was asked like 19 times in last 3 months. Google has asked 3 times in last 6 months, and then 6 months ago, Amazon, Microsoft, Bloomberg, and Visa. All these companies have asked, but Meta is very popular. So that's good to know. We can also start targeting the companies. I think I need to create a proper plan for learning and stuff. But yeah, with that being said, let's get started. 129. You are given the root of the binary tree containing digits from 0 to 9 only. So what do we have here? Root of the binary tree. And we are given, it will have number, can be from 0 to 9, right? For example, root to the leaf path is 1, 2, 3, represents the number 1, 2, 3. So if this is 1, this is 2, then this is 3. So this path represents number 1, 2, 3. Return the total sum of all root to leaf numbers. Test cases are generated so that the answer will fit a 32-bit integer. A leaf node is a node with no children. So if we have 1, 2, and 3, output should be 25. Why? 1, 2, that's 12, plus 1, 3, that's 13. So this is interesting. I thought it would be just leaf nodes. Go to the leaf node and find, but this is interesting. So this will be 495, 495 plus 491 plus 40. 495 plus 491 plus 40, 1026. This is interesting. Okay. So need to find something. Okay, I don't mind about this. So we have root, right? One node, second node, third node. Here, one node, right? So if the case is like this, I think recursion is a beautiful way to get this one out. What we have to do is, now I'll explain to you how I do recursion because I was taught by my school instructor, like my computer science. teacher in school, and it has worked very well for me since then. So in recursion, I don't even know if I'm typing it right. I don't care. I think there are three steps. One is base, the step one base condition. Second is intermediate condition. Third is the third is like when it will be what it will be returning, right? Third is the return one. And if you don't know one, you don't have to know all of these. You just have to know at least like start from somewhere, and we can figure out the other two later, right? So that's our goal. And let's start with the coding of this then. So there is base condition. Base condition in this case, I believe, is pretty simple to understand. Base condition is if root dot left equals none and root dot right equals none, return whatever is the sum. Actually not here. I'll create another function. There I will type it. Define get sum, let's say, self node with, I don't know if it will be a root node or a leaf node or what in between, right? One of the branches. So that, and then sum till now. If the base condition is if this is the last node, right? Base condition leaf node. Then if it is a leaf node doesn't have left or right. So node dot left is equal to none, equal none. And both of these conditions should match. Node dot right equals none. Both are none. Then what we'll do, return the sum, but sum has to be updated. Its value has to be sum equals whatever is the sum times 10 plus node dot val, right? Because how it is working is if it is 1 2 3 case, right? 1 2 3, I have 1 here. I start with 1, it becomes 1 2 here. It will become 1 2 times 10 plus 3. So it will become 123 here, right? That's the thing. And then we'll return the sum. Next is, instead of the base condition, right? We will have intermediate. I don't know about it, so I don't care. Let's say I don't know about this. This is how I'm thinking. Real life, right? I actually don't know about this. Intermediate actually would be like, what intermediate would be like if I think about my drawing, right? I started with 1, I added that to the sum. I'll go to the left and right. So if there is a left, I'll go to the left. So if node dot left exists, right? I'll just do this if it exists. If it's none, it won't go in there. Self dot get sum node dot left and then sum. And we can move sum here actually outside. Assuming like node always will have something value. left, because left is there, right? Not equals to none for people who don't get it. It's hopefully, right, it's not everybody is like so fluent in Python yet. If node dot right not equals to none, same thing but with the right one. Now sum is here, this is 1, left will return something, right will return something, right? So if it was, for example, our case was 1, 2, 3, and this is 4. So what happens is, when we are going down, right, when we are putting the stack, let's say stack goes from bottom up. So when we are here, sum will be equal to 1. Then we call recursion and we reach 2. So sum will become 12. Then split happens and we are first going to the left one. So sum for now here will be 1, 2, 3. We need to return this back. Once we go here, there is no leaf node, right? We will go return the sum. So here we need to destroy this and store this somehow. So we'll have another variable 1, 2, 3 from left. Let's say left sum, and then we'll have we'll call the, we are at here, right? Now we'll go to the right one. It will become 124, and then this will also return back. So 124 node, some left, some right. This is how it will be. Then we have to add, right? Then we have to add these ones, and then this will return as well. This will get destroyed. This will return. So sum will be 7, 4, 2. That's how recursion is, bottom up, right? And that will happen at the very end, because when we don't want to just change the sum directly when it's going to 4. We want to change the sum value left and right when both are returned and we are sending it to the parent. If you do it before, you're changing the value. Sum left, and we'll initiate sum left and right before this, so there are no issues. Sum left will be equal to sum right in the start, and both are equal to 0. Then we will have sum right equal to this, and this will also change to right. Now what we do, return yeah, we'll return sum left plus sum right. Why sum left plus right is not the sum itself. If there were none of the files, then it will return. If there was something, then it will go, and it's to the leaf node, right? So this should do the job, and our condition will be self dot, here we'll just return, and we want to set up the default value of sum. Then self dot get sum root and 0 for now, right? And it will return everything. So let's see if this works. Okay, worked for both cases. I will add another case just to check our stuff. Okay, let's see. Okay, (0 to 9) value. Okay, cannot access local variables and where it is not. So it went to left first, then some right. Okay. Oh, my apologies. Beautiful. So this will work. Awesome. And we beat 100% of the runtime. That's amazing. So this was a good problem. Just had little bit interesting idea to it. A small twist. Which is nice, which is good. Like I like this small twist here and there. Okay. Let's put it in our flex zone for the Discord. Oh, race condition. That's awesome. My man. That's good. I like when people put their stuff. Uh, LeetCode 129. What's the name of this? I'll do a link as well. Link, and then I have this. Yeah, today I think is the weekend, right? And everybody had exams and stuff, so that's why a little bit less chatting today. And today, this is not the time I come usually. I come 1 hour early. So maybe, yeah, today is like, it has been a very interesting day indeed. Like I was talking about, right? I woke up so badly from a very bad nightmare, and I was like scared, really, really scared. Happens. What else was there? What's this? Yeah, where's the gang? Where is my gang? Oh, actually, also Panda, I don't think you can use the everyone because then everyone will abuse it, right? Wait, you are a moderator though. Yeah, you can use it. You are the very few people who can use it. Okay, I just need one thing. No, it's actually like because what happens, simple reason of this is because a lot of people like to in yeah, you already know you are actually were the one who helped me create this, so you are the OG anyways. And I will put the code here. No, no need to be sorry. You are right. Like you are a moderator, but and it was like a simple question. Where is everybody today? Okay, flex zone. Let's go. This is done. Cool. So yeah, that was it for today. I think it was a very small stream, but I want to check couple of things. One second, let me stand up. Damn, chapter 7 in just 3 days. Good job, Panda. Okay, yeah, no problemo. I want to see what else can we do. I think we'll stick to this one problem a day, not get ahead of ourselves, but weekly contest Saturday. Starts in 20 hours. This is cool. We might do some contests from now. Bi-weekly starts at the morning. Cool. 10 lead code. Happy lead coding. I like that. I'm just thinking, like, in the sense, the problems, the quest. I want to, like, maybe look more into these things. What I will going to do, yeah, yeah, because, like, I did the problem, right? I kept like one problem a day. But what I'm thinking is I want to come up with a plan for this as well as try hack me on creating a proper structure to master everything, whatever we have in our stuff. Because there's dynamic programming arrays, right? Linked list, recursion one, recursion two. Dynamic programming is kind of my weak point, which I need to get out of the way. But also there's algorithms. There's not just data structure. Bit manipulation is also one. Just two things I'm very like scared to touch. Kind of like not good at. There's bit manipulation, then there is also algorithms. Certain algorithms I need to like be more comfortable with. There's Apple ones, Amazon specific companies related ones, so that's good. Yelp, Adobe, yeah. Okay, yeah. For today, this is it. But like for tomorrow, right? What we'll do is we'll spend time working on two things, right? First, we talked about planning our penetration tester one, right? There's a lot of hack the box, one hub, a bunch of like things which we can prepare along with like try hack me rooms which are not in the penetration tester one to first do that. Second, nailing down the concepts every week, like learn about a concept and just do at least like 5 6 problems on those from at least like 3 4 easy problems, right? And then medium and then hard, like maybe 2 weeks we spend on one concept and stuff. We'll see. In one quarter, just visit everything and just keep running the same cycle. So we are used to of things. Let's see what we'll do. But yeah, that was it for today. That was it for today. Nothing else. It unless until you have any problem you want me to do from lead code, like a easy one or medium, we can do that. But this medium problem was good. Interesting approach to path sum from like instead of just leaf nodes, we are calculating that. Yeah, it was a short one. It was a short one, but that's like I remember I mentioned because of some night shift work I have to do. I have to like make lead code ones smaller to from 30 minutes to 1 hour streams, right? Yeah. So yeah, but that's all everyone. Thank you so much for joining. Thank you, Panda, especially to you, right? And I'll see you guys tomorrow for some AMA, watching some YouTube videos with me, right? And planning our try happy. Till then, thank you so much, everyone. Hope you have a great day. This is your favorite censored hacker signing off with a big bye. Bye. Bye, Panda. Thank you so much. Peace out.